Most people think only about today. Everyone wants success, but very few are willing to wait for it. We live in a world addicted to instant gratifications, fast money, quick results, overnight fame, but nothing great happens quickly. Every meaningful achievement is built over years of patience, persistence, and vision. Look at Apple, Amazon, Tesla, giants today. But they are not built overnight. Amazon started just as an online bookstore. It barely made a profit for years. People laughed, investors doubted, but Jeff Bezos wasn't thinking about the next few months. He was thinking years ahead. He reinvented, improved, and grew step by step. That long time mindset built one of the most valuable companies in the world. Hope you all adopt to that long time vision. And to all my viewers today, I'm coming into the topic here that is on test of significance. We are going to discuss about the chi-square test of goodness. So I've already explained few examples in my previous video, and in today's example is fit a binomial distribution to the following data and test for its goodness of it for the level of significance 0.05, as this is most important. The number of heads are given as 0, 1, 2, 3, 4, 5, and the number of tosses 38, 144, 342, 287, 164, and 25. If you make an addition, so this will be 1000. So as usual, we are going with 5 steps, that is null hypothesis. Binomial distribution is good fit. Alternate hypothesis, binomial distribution is not good fit. See here, the number of heads and number of tails are half. P is equal to half and Q is equal to half. Calculation for test statistics. So here, the total frequency is equal to 1000 here. And now here, see, if n is equal to 1000, the expected frequency for each of the number of heads. So here we have to calculate the expected frequency for the number of heads 0, 1, 2, 3, 4, 5 are given as. So this is the formula here. So this formula is so important that f of x is equal to n times of n cx p power x into q power n minus x. We have to keep n values as x values as 0, 1, 2, 3, 4, 5. So for x is equal to 0, see here in place of x, in place of n5, in place of x is 0 and n is equal to 1000. So this is 1000 into 5c0 into half times of 0 into half times of 5 minus 0. So this will be anything to the power of 0 is 1 and half power 5 is 32, and this is already 1000. So 5c0 is 1 again. So we got the value, the first value as 31.25. Clear. And next one, for x is equal to 1 here. So we have to substitute in place of x as 1. 5c1 p power 1. So p is equal to half power 1, q half. Half power, this is 5 minus 1. Again 4, 1, 5. 1 by 35. So 5c1 is 5. So the value here is 156.25. So x is equal to 2. So in place of x, if you keep 2 here, 5c2, half power 2 and half power 5 minus 2. So this is 2 and 3. Again 5, 2 power 5 is 32. This is 1 by 32,000. So here 5c2 is nothing but 2 backward steps. 5 into 3 into 1 into 2. So if I cancel this one, this will be 10. So here you can use your calci. This is 312.5. And next one is x is equal to 3 here. So in place of x, if you keep 3, in place of small n, if you keep 5. So this will be 5c3 p power 3 and p and half power 5 minus 3. So this is 2, 3, 5. Again this is 32 and 5c3 is nothing but 5 into 3 into 5 into 4 into 3 and 3 backward steps. 1 into 2 into 3. So this will be 6 and therefore the value is equal to 312.5. For x is equal to 4 and x is equal to 5, these are the answers. Clear? So these are all the expected values. Now we are going to compute the table for chi-square test. So the number of heads here are 0, 1, 2, 3, 4, 5. Clear? And the next one, observed values are these from the question here. From the question, we have all the values. So all the observed values from the question here. So this is the question. See, let me show you the question here. So these are the questions. These are the observed values, that is 38, 144, 342, 287, 164 and 25. So we have to put it in column 2. And the next one is the expected frequencies. Just now we have calculated, that is 31.25, 156.25, 312.25. We have to place it in the third column. And the next one, we have to make a subtraction. 38 minus 31.25 is this one, 6.75. And 144 minus 156.25 is nothing but minus 12.25. We have to fill this fourth column. And next thing here is we have to make a squares out of this column. That is 6.75 whole square divided by E. E is nothing but 31.25. The value here is 1.458 minus 12.25 whole square divided by 156.25. We'll be getting this one value. So like this, we have to fill this column and we have to make an addition. This will be 8.9184. So we got the final value, that is chi-square value, as this value is a sigma value. Sigma OI minus EI whole square by EI, the value is 8.9184. So here the level of significance is given as 0.055% level of significance, and the critical value. So from the table we have to check the critical value here. N 1, 2, 3, 4, 5, 6. 6 minus 1, the degrees of freedom is n minus 1, which is equal to 5. And for 5 degrees of freedom at, see here, this is the critical value table for chi-square test. So for degrees of freedom 5, so we have to go with 0.05, that is 11.070. So here this is 11.070, as this value is the calculated value and this is the tabular value. Clearly 8.9 is lesser than 11, and therefore, so what is it, we have to give a conclusion. So we clearly know that the calculated value is less than the tabular value, and therefore we are going to accept the null hypothesis, and we are going to accept the null hypothesis. And therefore the last one is the decision. Since the calculated value is 8.9 and therefore the tabular value is 11.7, so we are going to accept the null hypothesis. And the next question here is the 10th question. A survey of 240 families with 4 children each reveal the following distribution. See here the number of male children and the observed frequency here. So here 4, 3, 2, 1 and 0. Here are the observed frequencies, that is 10, 55, 105, 58 and 12. And let the null hypothesis here H naught, that the male and the female are equally probable. So half. So P is equal to Q is equal to half half. So P value is equal to half and Q value is equal to half. So we are going to calculate the expected frequency of the male births are given as, see here, f of x is equal to n times of NCX P power x and Q power n minus x. So here n value is very clear as 240. See here the number of families here are 240. And n is equal to 4. So here n value is equal to 4 and 0, 1, 2, 3, 4. So now if you keep x is equal to 0 here, so in this formula, that is 240 into n 4c naught half, p is equal to half bar 0 and half bar 4 minus 0. The value here is 15. And next one, if you keep x is equal to 1, see here 4c1, p bar 1 and again Q half power, that is 4 minus 1, the value here is 60. And for x is equal to 2, the value is 90. For x is equal to 3, the value is 60. And for x is equal to 4, the value is 15. So here it is also very clear. 4c naught is 1 and 4c1 value is 1. And 4c2, it is very clear. 4c2 is nothing but 4 into 3 by, this is 1 into 2. If you cancel this one, the value here is 6. 4c3 is nothing but 4 backward steps, and see here front steps are 3. So we can cancel these two, and what remained? 4 remained, and 4c4 is again 1 and this is 6 here. So if you calculate all these, you will be getting the expected frequency. The expected or the theoretical binomial frequencies of the male birds are, the first one is 15, 60, 90, 60, 15. So these are all the expected values. Now let us apply the chi-square test to examine the goodness of it, of the given data of the above binomial distribution. So this is the table here, the number of families. These are the observed frequency. These are the expected frequency. So the observed frequency table from the question, that is 10, 55, 105, 58 and 12. So this is in the first column, and the expected frequency here, this is 50, 60, 15, 60, 90, 60 and 15. So this will be placed in the second column, and we have to make a subtraction, that is OI minus EA. 10 minus 15 is minus 5, 55 minus 60 is minus 5, 105 minus 90 is 15. Like that we have to fill the third column. We have to make the squares. Minus 5 square, minus 5 square, 15 square and minus 2 square and minus 3 square, and we have to divide with E. So this value is 25 by 15, the value is 1.67. 25 by 60, the value is 0.42. Like that, we have to fill this column, and now we have to make an addition out of this. And this is the formula that sigma chi square value is equal to sigma oi minus ea whole square by ea. The value is 5.26. Here the degrees of freedom. See here, 1, 2, 3, 4, 5. 5 minus 1, 4. At 4 degrees of freedom, we have to check at 5% level of significance. See here, this is the table, and 4, the degrees of freedom is 4, and we have to go with 0.05, that is 9.488. So this value is equal to 9.48 from the table, and therefore this is the calculated value and this is the tabular value, as the calculated value is less than the tabular value. And see here, since the calculated value of chi square is less than the tabular value, now we are going to accept the null hypothesis and conclude that the male and the female birds are equally probable. And this is how we have to solve using the chi-square test. And in my next topic will be the chi-square test for independence of attribute. That will be the last topic, and there will be 2 more videos uploaded in this playlist. Definitely, if you really like, just follow all these videos one after the other. There are very few, and definitely you will get an idea of attempting to the question, and definitely you can score more. And if you really like, you know what to do, raise your thumb, pass it on to your friends, and subscribe to this channel and stay connected.